The Module 3 Topic 1 review. We've learned how to solve exponential equations, and we've also learned how to graph and write exponential functions. So we're just going to review those two concepts. So I'm only going to do number 1 and 3. Number 2 you can do on your own. So for number 1, let's follow the steps we just went over in the previous lesson. We're going to rewrite the 81 so that it has a base of 3. So you can use Desmos to help you do that, or any other type of a calculator. But if I were to rewrite that, I would just keep multiplying 3 times itself until I get to 81. And I can see that 3 to the 4th power is equal to 81. So I'm going to rewrite my 81 to be 3 to the 4th power. And then just bring down the right side of your equation. From here, now that I have the same bases, I can set my exponents equal to each other. 4 is equal to x minus 1. And then you're going to solve for x. So let's start by adding 1 to both sides of our equation, and we'll get that x equals 5. And that is my solution. And it's a good idea to substitute that back in, the 5 for your x right here, and see if it really does equal 81. So we can try that out. If I substitute the 5 for my x value, I'm going to have 3 to, I don't remember the power, to the 5 minus 1 power. I'm just substituting my 5 for my x because I solved and I said that x equals 5. And I can see that it does in fact equal 81. So I know for sure that I got my answer right. Okay, so for number 2, you can solve this one on your own. Start by changing the 16 to have a base of 2. All right, and then let's spend some time together on number 3 here. We're going to make a table of values for the exponential function y equals 5 to the x power. So let's go ahead and do that. We can substitute in a -1 for x. That would be 5 to the -1 power. So all I'm doing is I'm substituting these x values for my exponent. So 5 to the -1 power is going to be equal to 1/5. If I substitute 5 to the 0 power, that's just 1. 5 to the first power is, it's just 5. And then 5 to the second power is 25. And then I'm going to use the table to graph my function. So I'll go to the left and up 1/5. I'll go to 0 and up 1. I'll go to 1, which is actually right here because this scale goes 1, 2, 3, 4. So be careful with the scale. Go up to 1, over to 1, up to 5, and then over to 2, we're going to go up to 25. And this is our sketch of our exponential function, which is going to continue going up. If I were to keep adding numbers here, I could keep finding more and more values, what my y value would be equal to. And I could also continue going to the left, -3, -4, and I could continue getting values to the left on the x-axis. Okay, so then another thing to review is that when we have an exponential function, the number in this place of the a value, that's going to be your y-intercept. And in this case, it's just a 1. And we've got a 0 in the place of the c value because it just says 5 to the x power. So we don't have an a value, it's just 1. And you can see right here on your y-axis that it crosses at this point 0, 1. You can also look for the common ratio. That's the b value, which in this case is 5. And then we can also look at the C value. That's our asymptote. So the C value, whatever your C value is, that's your asymptote. And that's just this horizontal line right here. That's your asymptote. And your graph's never going to cross that line. So if you want to see it a little better on Desmos, it might be a little better to look at it on there. You can see that no matter how far to the left you go, your graph's never going to go below that line, y equals 0. That is going to be my asymptote. So that tells that says when you're looking at an exponential function that your graph only exists above that line. It doesn't exist below it at all. Like there's not ever going to be a value that is less than 0. So that's my asymptote. And then finally for number 4, this is the pay it forward. It says a student, Trevor, comes up with an idea that he thought could change the world. He decides to do a good deed for 3 people, and then each of the 3 people would do a good deed for 3 more people, and so on. He believed that before long there would be good things happening to billions of people. At stage 1 of the process, Trevor completes 3 good deeds. So stage 1, Trevor does 3 good deeds. So here's Trevor right here. Here's stage 1. He's done 3 good deeds. And then for stage 2, each of those people are going to do 3 good deeds each. So that means that you got 1, 2, 3, 4, 5, 6, 7, 8, 9. So stage 2, there's going to be 9 total good deeds. And then each of these people are going to also individually do 3 good deeds again. So they're going to go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Each of them is doing 3 more. So then what would stage 3, stage 4, and stage 5 have as far as the number of good deeds? So you're going to make a table and you're going to graph those. So we're starting with 3 good deeds. We're going up to 9. And then how many is going to be in stage 3, stage 4, and stage 5? You figure that out. And then you need to figure out how many would be done at stage 7. So if we have 6 and 7, how many good deeds will be done? And then finally, we're going to review how to write a function that would model this process. So if you could remember, I showed you guys how to go to Desmos and put, You're going to go to Desmos and put your table in. So this is your table on Desmos. And then once you put that table in, you're going to use your exponential regression formula. And it's going to give you an A value, a B value, and a C value. And you need to plug those in order to get your function.